In this example, I will show you the general concept for creating 3D elements. Assume we want to create this geometry. Then we need to have first 2D element called profile, which should be swept out on another 2D geometry called guide curve. And by that, the application will find the external boundaries for the 3D element. Consequently, extra operations will be done to find the faces and edges, and also the vertices that relate to the produced geometry. Then, let's see how to work it out. Okay then. Let's create the first two-dimension element. Now, let's create the second two-dimension element. Then let's create the 3 dimensions geometry. Click one of these commands and use the profile and guide curves. As you see, the profile is swept along the guide curve. Then click OK to confirm. As you see, the geometry now consists of faces. And here we have edges. Also, we have vertices. As you know, this application's name stands for Computer-Aided Three-Dimensional Interactive Application. Then, let's see some of its interactivity. Double-click Sketch 1. Add corner to the rectangle, and then exit the sketcher. As you see, corner it to the geometry automatically. One more time, double-click Sketch 1. Delete the rectangle, and create circle, then exit the sketcher. You can see the geometry is updated according to the new modifications. Okay then, let's undo the last two operations. Okay then, let's have a look at the data structure for the 2D elements. It consists of two portions: the 2D specifications, which the mathematical and geometrical formulas, and the input data, like the values or coordinates that we supply. Such data structure will be used for all 2D elements, like the spline. However, in the case of 3D geometries, in addition to the 3D specifications and the normal input values and parameters, 2D elements will be used as input as well. Okay then. As you know, in Windows, We normally manage our files by using the directories or folders. In this application, similar structures will be used as well. For example, we have bodies, which could contain 2D and 3D elements, and other features and operations. Also, we have parts which could contain one or more bodies. From other side, one or more parts could be located inside one product. Then let's have a general look on these type of directories. Okay then, let's see the benefits behind using these kind of folders. Starting with bodies. We use these type in order to simplify the complex design. As you see here, this side is most difficult one in creating this part. Then to make it easy to be done, the easy portions are produced inside one body, called part body, while the difficults are created separately in body 1, and then assembled to the first body. Okay then, unlike the bodies, parts and products are documents. In other words, they will be saved on the hard disk separately, which means we can break down the large designs into portions and then reuse them anytime we want. The parts documents will be saved with extension of cat part, while the products will be saved as cat product. Speaking of the names, normally after loading the parts and products in the memory, then they will be called components. From other side, we have special type of the products, which cannot be saved on the hard disk, and they always loaded in the memory, as long as the parent product is opened, like set 1. This type is called non-document component or even just component. You can see the document components have a paper symbol, while the non-document is not. Also, we see here the part has a red axis system symbol, which means all the geometrical data are to be saved inside the part documents, while the products are only to carry the components management information. And that is why, unlike the parts, the products have small size. Okay then. Finally, if the geometries, like the 2D elements, or even surfaces, are to be used as input data to create 3D elements that located in many parts or bodies, then in this case, it is highly recommended to create the input geometries inside special folders called geometrical sets, which means the data will be safer and your design will not be affected if sometimes one of the bodies is modified or deleted